So the process of identification of classes, like for instance, we had this discussion about the zip code, right? In our situation with the zip code, we decided that it really depends how sophisticated we want to keep it. So tangible objects corresponds to a thing or physical sense, like keyboard, valve, sensor, railroad crossing, building, apartment, everything that you can model as some sort of physical space or a certain thing that corresponds to something that exists in the real world. A role such as a person can be an instructor, a student, and also an employee can be, and at the same time, it's interesting that you can have an instructor who is also a student, right? As an instructor, I could decide to take an art class and could become also a student, right? So the roles that different entities play in your application essentially can correspond to the birth of a class. Also, like input file, output file, file path, right? All of these things could be very, very useful as separate classes, right? I don't know how relevant it is, but if you will, all of a sudden, if you think about a file, right? I can think about a file, and I can think of, for example, I can think of a file on my file system, right? And the file can have a whole bunch of attributes, like for instance read-only, access levels and stuff like that, but it also can be connected to a path, right? The path on the file system. So the path on the file system, which simply is like the root, etc., passwords, something like that, is just a string, but the string can answer many questions, right? So the path that encapsulates a string of characters, which represents the path on the file system, could give me an answer like, is this a file, right? Is this a directory, right? I can have methods that answer those questions. I can also say what is the device, right? So this could be mounted on certain device, and I can answer that question as well by looking at the path. I can also say what is the name of the lowest directory, right? Sometimes I would like to know, so if this is a file, right? So this portion is a file. This would be my lowest directory. Essentially, the directory to which this file really belongs, right? So anyway, so this becomes very, very helpful with whole bunch of things like that. You can also, depending on your file system, you can find out what is the inode for that path and so forth. Anyway, so these are just examples of what different things could be playing, as they play different roles in our systems. Incidents, basically events, occurrences, meeting interrupt, error, keyboard key press, mouse click, and so forth. They can also develop them, you can develop them as sophisticated objects. Well, when I'm saying sophisticated, they're not so much sophisticated, but program as separate classes. Interactions. We already said that there could be objects resulting from associations between objects, right? So we can have a course registration. It actually does sound like an event to me, but at the same time, you can have a class which persists that, right? So that event takes place, we create a course registration, right? But then this interaction that someone registers for a course could be saved with all of its information into a database and essentially can be retrieved later and continue to be a meaningful class in the system. So interaction between different parts, different entities, events and entities, use cases. Sometimes you want to consider what interaction or what connections exist between different use cases in the system. That would also be that type of that class of objects that you may want to realize. For instance, in our semester project, an example of interaction is the simulation, right? If we say, okay, we enter some sort of configuration of the building where we want to have visitors to the building and elevators moving and all that, then how do you manage that, right? We can say, we could name it a running scenario that we already configured, or we can just name it simulation, right? So, again, there could be an interaction which brings the entire system alive, and you may have this high-level class that manages the rest of the dynamics in that application. So specifications, basically configuration descriptions, sometimes simply collections, sometimes more complicated, like hierarchical, structures. But they primarily responsible for providing description of something which can be used by examining the entire sequence of all of the attributes. So recipe, graduation requirements, and so forth. So these are examples of that. In our case, again, a scenario object would be a specification for simulation, right? Because before the simulation begins, we would like to specify the parameters, and we say this is our scenario, right? Another look at attributes. It again depends on the problem, the complexity of the problem that you're trying to solve, right? But you want to know, for instance, the specifics of your attributes. Why? First of all, you need to decide how, what data types to use, right? Essentially, you need to examine your attributes from that angle, and in the process of understanding what types of attributes you need, you say, okay, is this descriptive? It basically provides some kind of characteristic. Is it naming something? Naming and identifying things is extremely important, because oftentimes, an address in computer memory could be identifying something. Sometimes you can have a unique sequence number in your database table. That would be an identifier. And sometimes you can find unique characteristics within your own problem domain, such as social security number, or phone number, or zip code, or state name, and so forth, right? Or person name, a combination of first, last, and so forth. So understanding the specifics of that unique identifier to your entities and your objects may impact whether you choose to store your social security number as a number or as a string, right? So it depends. It depends. You have to examine your use cases, how you're using it internally, externally. Would you allow it ever to change? What if someone entered it incorrectly in the first place? And how easy would that, how much dependency your system has on the Social Security stored internally in the database as a key to access records? What do you do in this situation? Sometimes you can just say, well, you know what? It's okay to make a mistake, and instead of deleting that or replacing an existing Social Security number with a new value, you may basically mark that existing record or that entity as inactive, okay, and create brand new one or clone it with new Social Security number and say, okay, it has been corrected, but it all can be done differently. It depends how much audit, how much history, how much accuracy you want to maintain in your application. So there are lots of things that need to be considered with identifying stuff. And if you decided to store information and persist information in some sort of database or file or a combination of files, all of a sudden you have this identification challenge. How do you find those things that you already stored? What do you do to locate those things? How efficient the process, the search process is? Would you like to store everything pre-sorted, or would you like to, if you need to do some kind of binary search, you need to sort it first? Do you sort it in memory, or do you save it already in sorted order? And there are lots of things related to identification and efficiency of searching for your data, and that of course is relevant to some sort of the idea of naming or identifying. So clearly the demands of the entire system make an impact. How would you want to internally store your Social Security number, ID, or phone number? Do you store it in what format, and so forth? And referential attributes, of course, tie objects together, right? So like we said in our example earlier, in this example over here, is that if we have the property owner, it can hold the title, it can hold the reference to the property. So essentially these associations that we create between the objects do represent those referential referential attributes, right? Sometimes those referential objects are collections, right? In our case, again, I'm hitting the wrong picture here, right? In our case, most likely the property owner can own multiple properties, right? So very likely that what we would like to do with this design is that we would like to specify that the same owner can have multiple properties and provide that information here, but it immediately impacts the way this association internally is implemented. Of course, there needs to be a collection internally stored by the property owner so that they can accommodate multiple properties. Okay, so these are referentials. Class diagram we already discussed earlier consists of boxes that represent classes. Of course, we have these three areas. Like I have this address over here, which is the name of the class. Then I may decide to also have a section with specific attributes, and eventually I may also decide to have a section where I will be placing my methods. Of course, this my fantasy here, but it's not standard UML, right? So in standard UML, you just have boxes with these sections that are designated for class names, attributes, and methods. But the important thing to remember is that a class diagram by all means is not enough to properly describe your classes. Most likely there needs to be a separate document which provides the description of your classes, the purpose and information, like for instance, at least why did you decide to add this class? Why do you need this class in your system? Okay, so moving on. Finally, we begin to hit this area important to us in today's discussion. How do we assess the quality of this design? How much, how does it stand the idea that this design can be taken and used in writing the actual software code? So, aspects to consider, and it's quite lengthy. It's surprising that there's a basically long list of things to worry about and to be aware of and to discuss, right? So quality of abstraction. So again, abstraction, it just like, it amazes me how often it surfaces in this discussion of object-oriented design and programming. But abstraction simply means that things in the real world are tangible and physical, or very, very well specified, like in math, right? If you have the rules to solve, certain equation, it's pretty hard stone. You can just follow certain steps to do that. But in software, it somehow needs to be abstracted in computer memory. Right, so everything in software is abstract because it only, tries to do to emulate things that are happening in the real physical world. So the quality of abstraction here would be, it would have multiple components, right? In fact, everything down here is could be defined as element of abstraction. But I think on this specific slide, what I'm thinking of is simply how well do we abstract what property is, right? We said it could be a land, it could be a residential property, commercial, a farmhouse, multifamily house, apartment building, and so forth. Does that fulfill the needs of our, specific problem, our application? If it does, that's a good abstraction. If it's not, if it's not doing too well, for instance, we could have the land, the residential, commercial, and farmhouse without formal property. That would be not a good idea. That would be perhaps not such a good picture after all, because they're all related. They're all can be abstracted, with property being the common ancestor and specific types over here being the derived types, right? So that's the type of abstraction perhaps on this slide that we refer to.